Okay, we can get started.
All right, good morning, class.
Good morning, teacher.
You are welcome to this class, and I am your teacher, Mr. Samali Moses. I'll be taking you through the mathematics class. Just a quick look at, I know who is here. Is a team Andrew there?
Yeah, I'm there.
That's very good. You're welcome. Jaffas, are you there? Jaffas? Jaffas, not there. Juliet Senyonjo, are you there? Okay, so class, let me request you to change your names. Please put your names, put your right names on the system so that I can be able, like the way a team, sorry, like the way Juliet Senyonjo is. Okay, so please type your name, like Mwanguzi Sheila, Nakato Sauma, Nandere Charity. You've labeled your names very well. Okay, so those who are having names like those who are having names that are not clear, please rename your devices. Galaxy A5, please give us your name. Galaxy S6, please give us your name. Okay, as we kickstart our lesson. Okay, so all of us, I hope we have our books near. Do we have our books nearest us?
Yes, we do.
All right, that's very good. So this is senior 3. I hope all of us are in senior 3. I hope we are all in senior 3. Are we? Someone was asking if this is senior 3. Yes, this is senior 3 mathematics. All right. So class, I'm going to take you through mathematics, and as I said, by names, Mr. Samali Moses, and I'll be taking you through the math class. And in math, particularly, we are going to look at a topic called probability. That's what we are going to look at throughout our studies. So as we get out our books, please, this will be our topic for today, probability. I hope we are all able to see our screen. Are we all seeing our screen very well?
Yes, teacher.
Yes. Yeah.
That's good. So probability is where we are. Now, when we talk about probability, this is a, please, I request that let's not write on the board, okay? Those of us who are there, please, let's not write on the board, because we all need to see it. So don't put any writing there so that we see everything clearly.
Teacher,
all right, yes.
I think we have many learners who are not putting on their audio, and so they can't hear you. They are in the text asking, teacher, we can't hear you, yet I displayed the message, they didn't see it. Let me display it again.
Please do.
But leave your computer, I mean, leave your slide on so that they can see from there. You get it?
All right.
Yes, I'm going to write there. Can see my text?
It's not seen. Okay,
It's there. Because they are there in the chat, we can't hear you, yet they didn't connect their audio.
Okay, so students, let's check what we have here. We are saying you try to tap the part or at the bottom. Okay,
No,
at the
they
bottom
can't
left.
hear you. Sir, they can't hear you unless they connect it.
Okay.
Yes, they can't hear you unless they connect. Okay, I see some are connecting. So they can only hear you once they tap to connect audio. Otherwise, they will just see the screen.
Yes, teacher, I'm hearing you.
Okay, now we can proceed.
Okay, so class, are we hearing each other now?
Yes.
Yes, teacher.
Jacqueline, you're there?
Yes,
Yes,
teacher.
Yes, teacher.
Okay, Caleb is there. Caleb?
Yeah, I'm there.
Thank you. So we are all hearing each other now, clearly?
Yes.
Okay. All right, thank you. So I was saying that we are going to look at probability theory, and it's a topic that we are going to move in step by step so that we get the concepts that are within there for our day-to-day engagements and also excellence in our exams that might come our way. Now, I request if you have any question, please you send a text there, send a text in the chat so that I'll keep on answering as we proceed. So probability. Now, do we know what a probability is? I'm sure we looked at this from primary. Baguma? Baguma, are you there? Baguma?
Yes.
Baguma, tell me something about probability. What do you know?
It is the chance of a possible digit appearing out of the total number.
A chance of a total. It is like a chance, okay?
Yes.
So we are seeing probability as a chance, okay? Any other, Damolida Peter, your hand is up. Tell us something about probability. Damolida Peter, your hand is up. Okay, someone using iPhone, your hand is up. Can you tell us something about probability? Yes. Ronald Wasso.
Probability is the desired chance of
the desired chance
over total chance.
Over a total chance. Good. So we are saying that when we talk about probability, we are talking about a chance of something happening. Okay, so something can happen, something may not happen. Okay, that is what we are looking at. So in mathematics, we look at how do we calculate a chance that something is going to happen. That is what we are doing. So when we come here, we are saying, we are here. For example, we have scenarios here. In each of these scenarios, does the outcome have equal chances? Now, chances can be equal chances, or the chances may not be equal. Are we together? So we are saying, like, take an example. If we say if we say that it will rain tomorrow, how many chances are there that it will rain tomorrow? Birunji? Birunji Liberty? How many chances do we have that it will rain tomorrow?
2 chances.
What are the 2 chances that we have?
It may rain or not.
It may rain or it may not rain. Okay, so those are 2 chances. Do we have any other chance? If it doesn't rain, then it will rain. Okay, so we call those ones as 2 chances. Then when we say a child that will be born will be a boy, okay, those are how many chances do we have there? Albert Faizo. Albert, how many chances do we have that a child being born is a boy?
2 chances.
What are they? What are the 2 chances?
The child could be a boy or it could be a girl, or there are many.
Yeah? Are you
There
sure?
are many because the person
Might. Pardon? Okay, so we are saying that the chances of that happening will be 2. If someone is not a boy, then it will be a girl. That is if they are to be born. Now, when we say a coin is tossed, when it is flipped, how many chances that a coin will show tails when it is flipped? How many chances do we have there? Charity? Charity, how many chances do we have? One chance. Jeffa says 1 chance. Okay. Jeffa says it is 1 chance that a coin will show tails when it is being flipped. Okay. So we are looking at chances that when something happens, there must be a chance, or 2 or 3 chances, or even very many, as someone would have said. So, like for example, let's look at this. If a number is selected at random from 1 to 100, how many chances are there? If we look at that, Caleb, how many chances are those? If
will be 99.
There will be
99.
there will be 99 chances, okay? Because we have a wide span of numbers. So, and so many of them, so many other events that can happen. Now, when we look at, when we come to, for example, take an example. We are still looking at, we are having the concept of probability. How does it come about? How do we tell? How do we predict something? So we are saying, take an example of a probability, tossing a coin. When you toss a coin has either a head or a tail. Okay, so it will either land on the head or it will land on the tail. So the chances that are there are 50-50, because it can be 50 head, 50 tail, because there are only 2 chances. So when there are 2 chances, usually the sample space that is there, they are always 2. Now, when you roll a dice, those of us who have played the games of the dice, the Ludo and everything. So usually when you toss that coin, you'll always get different outcomes. Someone can either choose to get a 6, someone can either choose a 5 or a 1, and so on. So those are the different chances that we do have. So when we look at this, there are 2 major terms I want us to get as we are looking at this probability. There are 2 major chances, 2 major terms I want us to look at. And these terms are, we have what you call a sample space, S. Now, when you talk about a sample space, we are talking about a set of all possible outcomes. All possible outcomes. For example, we said, when you roll a dice, okay, when you roll a dice, we have different outcomes, 6 different outcomes. So meaning those outcomes are what we are calling the sample space. We are saying when you have a coin, when you roll a coin, the coin has 2 faces. Now the 2 faces will become the sample space. That is the sample space. So how do we come to, for example, when you toss a coin, we say we have our sample space is either the head or the tail. So all the outcomes that are coming out of that given chance, we call them the sample space. Then when you roll a dice, the chance of the sample space will be 1, 2, 3, 4, 5, up to 6. So those are the possible chances that we shall have. So those chances are what we are looking at as the sample space. Okay. Now, and so many, who can give us another example of a sample space when something happens? When something happens and you tell us the sample space there. David, is David there? David?
Yes, I'm here.
Can you give us a chance and then you give us the sample space that can be there, a possible sample space?
Like when an accident occurs, there might be chances of people surviving or dying.
Very good. When an accident occurs, people might die or people might not die. So how many sample spaces do we have? How many items do we have in the sample space? David?
2.
We have 2. Very good. So we say that that is now a sample space. Okay. Let me choose Juliet Senyonjo. Can you give us also a possible chance of some Juliet Senyonjo? Are you there? Senyonjo Juliet? Not there. Jacqueline? Jacqueline? Someone is saying, Jeffa is saying, picking mangoes from a basket. So the mangoes might be raw or they might be ripe. So meaning we have 2 chances to the sample space is 2 there. Thank you, Jeffers. Who can give us a sample space which has more than 2? Okay. More than 2. Want a sample space with more than 2? Yes, Mariam.
Okay.
Mariam?
Yes.
Yeah.
A card, yeah?
Yes.
A card is picked when it is picked at random in a pack of 52 playing cards.
Okay.
Then it is then 4/52.
Okay, so you have a pack of 54 cards. Okay, you have a pack of 54 cards. So meaning the chances of picking out a certain card, meaning we look at that as our sample space. Very correct. Okay, so that becomes a sample space. The number of cards that are there, the total number that is there becomes the sample space. Good. Baguma? Yes, Baguma?
Picking things from a container. There will be red. Picking like a pen from a container.
Okay.
There will be red, blue, or black.
Very good. So meaning in the container, if you have red, blue, black, depending on the number that you have, the number of items there. So meaning we are saying our sample space there will be that. Okay. So that is how we will generate our sample space as far as that is concerned. So in our probability, we basically first look at the sample space that we do have. A team was telling us that picking balls from colors in a basket at random, that's also a sample space. So we have our sample space is black, red. There's someone who gave us something in a match. a sample space of win, loss, or draw. Okay, that is also a sample space. So the win, the draw, or a loss, the three become the sample space. Good. There's someone who gave us an interesting one here. The president lifting the lockdown or even hardening things. Okay. So that is Caleb. Caleb, could you explain to us how many chances we have there?
We
Caleb?
have two.
There are two.
We have 2 chances.
The 2 chances are?
Lifting or
hardening.
The other thing.
Or the other thing. Yeah? So those are now what we call the sample spaces. Okay. So most of the common sample spaces we get, like in a football match, we have a win, draw, or loss. So those ones become the sample space. Okay. So class, that is how there's also a woman giving birth. There is a probability of giving birth to a girl or a boy. That is very good. That is from David. Good. So I think we've exhausted most of our sample space. So what we need to understand is a sample space is all the total outcomes that we shall have. They form what we call a sample space. Good. Now, another thing that we look at is what we call an event. Now, remember our sample space, keep it in mind. Now, the second thing we have is an event. Now we are saying, and let me have Charity. Charity, can you read for us? Charity? Is Charity there?
Yes.
Good. Can you read for us what you can see there?
The event E is any subset of a sample space S, i.e., any set of outcomes into brackets, not necessarily all outcomes of the random phenomena
of a random phenomena. Very good. So when we talk about an event, we generate our event from the sample space. Okay. Now, for example, let me give an example that someone was saying. The probability, let's take a football match. So in a football match, our sample space, as we said, our sample space is either a win. If you don't win, it's a draw or a loss. So these ones are 3. Okay. So if you pick out an event, for example, if for you are very sure that a given team is going to win, so meaning the win becomes our event. Okay, so the event is generated from the sample space, a set of outcomes that is being picked out from our sample space becomes the event. When for you, you say, no, me, I'm very sure this certain team is going to lose. So basically, the loss becomes an event. Okay, so when we talk about an event, we are looking at what has come out of the sample space. What are you predicting? If you say tomorrow it's going to rain, so meaning it may rain or it may not rain. So once it rains, meaning the rain R will become our event. So meaning that event has occurred. Take an example, as we are saying. Let's look at this diagram here. I'm sure we must be familiar with the Venn diagrams. So in a Venn diagram, when you have your Venn diagram like this, the sample space is everything that is inside here. That is the sample space. The event is this given part here. For example, if this is set A, this set A is the event. If you have another set B will also be the event. So that is how we generate that's how we generate an event. That the event comes from the sample space, you draw it from that given point. So let's keep those 2 items in mind. that when we have an event, the event is said to have occurred if after the outcome has been observed, the outcome lies in E. The E is this one here. So for example, when you have different samples of items here and one comes inside here, so this one becomes, so here you may have maybe a football match, you have a win, a draw. But for you are very sure, it is a loss. So when the loss comes here, the loss is now an event. Okay, so what we need to know is an event is picked from the sample space. Take an example. When you roll a dice, this is what we have. Okay, this is our sample space. Now, what are the chances of picking out maybe an even number? Okay, what are the chances of picking out an even number when we have here? What are the chances of having an even number? Bagadila, Janet, could you give us the answer there? What are the chances of picking an even number from this sample space? Mariam's hand is up. Yes, Mariam?
It is 3/6.
Look at this. What are how many even numbers do we have here? Give us the even numbers here.
We have 2, 4 and 6.
4 and 2,
and
4,
2.
2,
And
4 and 6. Very good. So now this one here, the 2, 4 and 6 becomes the event. I want us to take note of this, that when you roll a dice, the outcome, E, the event of an even number appearing, will be, you pick out how many even numbers that you have. You first number them here, okay? You first number your events. So when you number your events, that is now when you can come up with the probability. So this event E, this one is now the event of the even number. The sample space is here, and then the event is right there. Okay, so these are the two items I want us to first get before we go to something else, because we are going to keep using them. We shall talk about sample space, and we shall also talk about events. But I want us to know that when you talk about a sample space, all the outcomes. When you talk about an event, we are picking out these outcomes from the sample space. Okay. Who has any question about events, sorry, sample spaces and events? So that when we go, the next thing is going to lead us to something that we are going to keep on dealing with, especially with events and sample spaces. Okay. So someone said the event that an even number is rolled out, you first list your even numbers there, and then the event is these even numbers. All right. Now, I want us to also to look at something about probability. I want us to look at something about probability. Good. Caleb got it right. Thank you. Now we are saying, when you are measuring, we are looking at the probability scale. How do we measure our probability? Now we measure probability on a scale from 0 to 1. Probability is from 0 to 1. When you go outside that, it's no longer probability. When you go to negatives, it's not. When you go to 1.1, 1.0, 1.1, it is no longer a probability. And on our probability scale, we are saying, if an event is impossible, look here, if an event is impossible or it has no chance of occurring, then the probability is 0. Okay? If an event is impossible or it has no chance of occurring, then the probability is 0. For example, when we say something, when you talk of something which is impossible in a given event, that means that one is a 0. Okay. Take an example. When you talk about, I'll keep on using those, when you're rolling a dice and you say, you know a dice has from 1 up to 6. But when you say, what are the chances that someone will pick a 7? Okay. Meaning this 7 here, the probability is 0 because the 7 doesn't exist here. So we shall say that probability is impossible. So it is 0 because you very well know the 7 is not part of the dice. So that's why we'll say is it impossible. Okay. So you'll have, like, for example, if you say you have a football, you have a game going on, and there is, we know our chances are loss, win, draw. Okay. The game has started. And then you say the chances are the game will not start. It means it will not be played. Meaning it is not, that is impossible because the game has already started. So not being played, it is not, it is, that is impossible. Who can give us some other impossible chances? Some impossible chances that you can think of that will know that the probability is 0. It can't happen. Yeah? Caleb. Is Caleb there?
Yes, I'm there.
Yes, Caleb. Give us any impossible event in a probability scale. Of course, the impossible, they have to be, one, look at the sample space first, then you look at the impossible part of it.
An impossible event is that, let me see.
Any that you think about, an impossible event.
Failing to do our examinations.
Failing to do your examinations. It is impossible.
Because you have to do it.
You must do it. Okay.
Yes.
Mubaka Shadra.
Any impossible
event,
just like saying that the cow will not calve down, yet it has already finished to calve down.
The cow will do what?
It's just like to say that the cow will not give birth. Yet it has already finished to give birth.
And yet it has already given birth. Okay.
Yeah.
It becomes impossible. Yes, Lydian. Lydian, your hand is up. Okay, Tracy. Stuma, Tracy.
Probability that you get milk from a bull.
Oh, okay, that's totally impossible. Okay, totally impossible. Very good. Tracy, Hope. Yes, Juliet, Senyonjo.
The probability of a girl becoming a boy.
A girl becoming a boy. So impossible. Okay. So I'm seeing so many suggestions here, impossible ones. Getting a mango from an orange tree, a girl to be born when is a boy already born, pausing lockdown when COVID is increasing, and so many other things. Thank you for those impossible events. A cow giving birth to a human being. I don't know if it is impossible. All things are happening. Okay. Okay. Giving beef from a hen and so many other things. So thank you for those impossible events. So this shows that when you are looking at a probability, there is a possibility that something may not happen. Okay, it will not totally happen. So we shall say that is a 0 chances of that thing not happening. Then what happens? So if a certain event has if an event is certain, it has a probability of 1. Like you have 100% very sure that that one is going to happen. Take an example. I'll ask, what are the chances that you are going to have lunch? There I'm 100% very sure that all of you are going to have lunch. At least that one I will say my probability of that is 1 because I'm very sure it is going to happen. Now, members, look at these decisions here. These ones help us when you are calculating down and your answer is 0. Look at this. 0 means impossible. Does it mean that if they give you a dice, maybe you have numbers from 1 up to 6 and they tell you what are the chances of picking 3, and you find you calculate and your answer is 0, and yet there is a 3 there, meaning you're saying that it is impossible. And when you calculate 1, if you say 1 and yet you have series of items, it means that your answer, you have to check it to be very sure that it is impossible or it does not happen. Okay? So when an event can happen, you're very sure it will happen. Like I was saying, that I'm very sure all of you are going to have breakfast. I am very sure all of you are in this class because I am seeing you here. So the probability that you're in class here, from what I see, is 1. Okay? So that becomes something which is very, very certain that you're very sure it is going to happen. Okay. Next, another thing, this is our scale. Now, when you are not sure, look here, when you look at this is our probability scale, that from 0 to this half, it means you are not sure it is going to happen or not. When you tend to this other side tending to 1, that the chances of it happening are higher. While here, the chances of it happening are a bit lower when you look at this. So this is our scale. Do not calculate your probability and you come to 2. Look at your answer if your probability comes to 2 or even 1.1. Okay? It means you need to check something. Okay? It means you need to check something. So as we are going to calculate our probabilities, make sure this is the scale. Can be 0.1, 0.5, 0.7, and so on. 0.1, 0.9, 0.99, but at most it should end at 1. That is what I want us to have in mind. When we are calculating our probabilities, I don't want us to calculate probabilities and we find our answers as true. That is not, it is not there in probability. Good. So this one is impossible. The other one is certain. And then this is an even chance. Even chances, it may not happen. It may happen, it may not happen. Okay, now probabilities, another thing that we need to know, that probabilities are written as, so David is saying, so which means at least it can be a half. Yes, David, it can be a half. Is okay, a half is okay. 2 out of 2 out of 3 and so on, as long as it does not go beyond 1. That is what I want us to know. Our probability should not go beyond 1. Now, so it can be a full. Yes, it can also be a full 1. It is possible. It can also be 1. Okay? Like for example, if they give you in a pot, they put 1. If they put 1 ball in a pot, what are the chances that you're going to pick out 1? It is automatically 1 because it is only 1 ball which is in the box. So that one becomes a 1. So it can be 1, but not 1 point something. Do not put any point. Okay. So we are also saying, Andrew is saying, do we also express probabilities in decimals? Very good. And this is where we are now. We are saying probabilities are written as fractions, decimals, okay, and less often as percentages, not always, but a bit we can write as percentages. For example, you can say, what are the chances of it raining? I say 50%, okay, 50%, meaning it is 50 out of 100. Okay?
Yes.
Good. When we say, so you can re-express our probabilities as fractions, decimals, and also percentages. Okay. Tracy, if we are to stop around 0.9, can we recurre each to 1? No. Please, probabilities, we do not round off probabilities. Don't have 0.9 and you say, please, once you get your answer at 0.9, keep it at 0.9 because it is a chance. You are picking it out because when you say 1, remember I told you that 1 you are very sure it is going to happen. When you say 0 point something, you are not sure. Are you together? We are saying when you say 1, it means you are very sure it is going to happen. As I said, what are the chances you are going to sleep today? It is 1 because you are going to sleep. Whether at what time you will sleep, so it will be you're very sure of it. But when you say the chance is 0.9, it means you are not sure you're going to sleep. You may sleep, you may not sleep. But when you say it is 1, you're very sure about it. Okay, so that's the reason as to why when you say 1, you're 100% sure. But when it is 0 point something, it is because there is a sample space. The sample space tells us that there are items that are there. It is possible something is happening. Now, when you put 1, most likely, like for example, when you have 20 balls that are red in one separate box and they say, what are the chances that you're going to pick a red ball? Of course, the chance is 1 because there are only red balls inside there. So that chance becomes 1, the chance that you're going to pick a red ball. So it becomes 1. So class, let's have this that, good. Let's have this knowing that that's how we get our probabilities. That as we come up with our probabilities, we should know that they are either going to be fractions, or they will be decimals, or at some point they will be percentages. Okay, please, someone writing on the board, someone, please don't write on the board. Please don't write on the board. That is someone. You'll be messing up our work, and we need it. We are going to write it down. Okay. So next, we are saying, final as we proceed this. So we are saying the probability of an event. We are now defining the probability part. The probability of an event, for example, if you have a sample space, this 0, 1, 01, 02, 03 up to ON, it has infinite number. There are so many outcomes that we have right there. Now, the probability of an event happening, okay, the probability of an event happening is calculated as the number of events. We've looked at what an event is. So, hope someone doesn't ask what an event is. Divided by the number of the sample space. This is what we have. And okay, let's see it clearly here. Let's see it here.
Excuse me, teacher.
Yes.
I beg your pardon.
On the formula?
Yes.
Okay, so we are saying if you want to calculate a probability, we are now turning towards calculating. If you want to calculate a probability of an event happening, it is an equivalent to the number of the event out of the sample space. I repeat, we are saying we have the number here, we have the number of the event out of the sample space. That will help us to find the probability of an event. And when you look, please let's look at these symbols here, okay? Let's look at these symbols. When you say N in brackets E, it means that the number of an event. Let's have an example here. Maybe we can see it clearly. Let's look here. Let's look here. Maybe we can get with this example clearly. We are saying when we are calculating the probability of an event coming out, we are saying the number of possible outcomes. That is the number of the event out of the total sample space. Take an example. If you have this bag here, this bag has different colors. We have the green, blue, red, and then yellow. And in this bag here, A bag contains 1 yellow, 3 green, 4 blue, and then 2 red marbles. Now, when we say what is the probability of getting a green? Okay, what's the probability of picking a green marble from this bag here? For us to get that probability, remember our probability, first of all, we get the event. Okay, we get our event. Our event is we have 3 green. Okay, so our event will be the 3 because what are the probabilities of picking a green marble? So you count how many green marbles you have. We have 1, have 2, we have 3. So the 3 becomes the event. Then the sample space. Our sample space is the total number of items that are inside there. And when you total up all those items that you see there, Caleb, how many do you have there?
I have 10.
We have
10.
There are 10?
Yes.
Okay. There are 10. So meaning our sample space here is 10. Please, we have the event. The event is 3 because we have 3 green marbles. We want to find the probability of picking out a green one. So look at the event. How many greens? We have 1, 2, 3. Those are the 3. The sample space is the total number of what is inside the pot. So our probability of green, okay, our probability of green will be the event, okay, out of the sample space. Okay, so the event is 3 and the sample space is 10. So that comes to 3 out of 10. When you change the 3 out of 10 in decimals, someone with a calculator there, Eric, maybe I'll
0.3. 0.3.
Janet?
It's 0.3.
Correct, it is 0.3.
3.
Okay, so do you see that our probability is less than 1 and more than 0? Okay, whatever you get should be less than 1 and more than 0. So this will be your answer. Now, can you calculate and tell me what are the chances of picking out the blue?
It's
the blue marble.
10, that's 0.4.
Event is 4.
The event is 4.
0.4.
What is the event?
0.4.
That is the probability. The probability is 0.4. Correct. Yeah. So, class, I want us only to learn about event sample space. Event sample space. So this will be our general item. This is what we shall be having. Okay. When we have our probabilities here, we are saying
without looking.
Okay, so we are here. So as we said, what is the probability of pulling out a green marble? And we say our event was 0.3, and then which is 30%. Now, how do you get the percentage one?
3.
So to get this percent, the one in percentage, you get the 3 out of 100 and you multiply by 100. So when you multiply by that, you come to the 30%. And okay, now let's finally look at this. Let's finally look at this, and you're going to work it out from there. So we have a spinner here. What is our sample space for the spinner? This one here that we have. Janet, please.
There are 8.
The sample space is?
Oranges.
Sample space is 8. Correct. Okay. Now, what's the probability of spinning and you get a blue? Caleb? Caleb, it is?
1 out of 8.
0.5.
Okay, let's start. Can we mute our microphones? Let's mute.
1.
Let's mute our microphones. Okay, good. So we are saying to pick out a blue, look for the event and then the sample space. The event is Eric. Eric, what's our event? What's our event? We say picking out a blue. Our event is 1. Okay. And our sample space is
8.
Our sample space is 8. So our probability will be probability of the event of the blue will be the event which is 1 out of the sample space which is the 8. Okay, good. Now let me also look at this. Let me look at C first. What are the chances of landing on a green of not landing on green? Please, let's mute as we are winding up. We are winding up. Let's mute our microphones. Good. So we are saying when you have an event, there is a possibility of it not happening. Now, if something does not happen, this is what you do. This is what you do if something is not supposed to happen. Can we mute our microphones, please? Those whose microphones are on.
I have already done this.
Those whose microphones are on, please mute. Okay, so I want us to learn something here before we go, before we move. Now, when you have an event of not happening, something not happening, for example, for this one, not landing on a green. So the probability, if you can, there are 2 ways you can do it. You can say, you can either first get the probability of the green and then you subtract, or you count the event. When you look at your event here, look at those ones that are not green. How many are not green here? Caleb, how many?
4.
There are 4. Okay. So the 4 becomes our event. And then our sample space is constant, which is the 8. So our probability will be 4 out of what?
8.
4 out of 8. Okay. Alternatively, you can also get, okay, I think let's take this one here. So the probability of that, it will be 4 out of the 8. Someone is asking, I think that is what, please don't mind about simplifying. You may simplify, you may not. But what matters is you can maybe change to decimals as well. You can divide this by this and then you get the answer there. So that will be easier for us. Okay. Now, when we talk about red or green, okay, here we combine the 2. So you look at the probability of red plus the green, and then you get that. So our event will be, okay, what is the probability? What is for red? How many reds do we have?
2.
We have 2 reds.
2
plus the greens. How many greens do we have?
We have
4 greens.
4 greens. So you'll get your 4 plus the 2, which will be 6. So your event will be 6, and your sample space will be 8. So meaning your probability here will come to 6 out of the 8. So literally, this is how we are coming up with our sections as far as the probability is concerned. So class, today, this is what we had to learn about. We've learned about two major things: how we come up with the sample space, and also how we come up with the events. And also, finally, we saw the formula. And the formula part is the probability is equal to the event, okay, out of the sample space. This is our class for today. And that's how I want us, we are going to start from that point. The next time we come, we are going to look at the unions, the intersections, how do we calculate them as well, okay? So thank you so much. Do I have any question? Do we have any question?
No.
Someone is asking, teacher, can a question come asking for an answer in decimals? David, yes, it can come asking for an answer in decimals. So what you do, you convert. Okay. Are we together? Okay. Otherwise, thank you so much for attending, and I wish you a good day. In our next lesson, we shall look at other details about that. So may God bless you and have a good day for now. I wish you a good day. All right. Thank you. Have a nice day.
What's up now?
Thank you, teacher.
You're welcome.
Thank you, sir.
You are welcome.
Thank you, sir.
You're welcome.
Yeah.
You are welcome.
Thank you, sir. Bye.
I think he has just